Okay, so drawing parabolas. The most standard parabola there is written in this format. Y equals x squared. If you can compare that to a standard linear graph that is written in this format. Y equals mx plus c, where m is the gradient and c is the y-intercept. So if I just draw the standard basic parabola for a moment, this is what it looks like. When I say draw, I'm sketching this one. So 0, 0, and then you go across 1, up 1, across 1, up 1, across 2, up 4, across 2, up 4. Okay? And it becomes a nice curve. Whoops. What I probably should have set up here was you would compare y equals x squared to the same thing as y equals x. Okay? Y equals x is just a straight line. Okay? You know why, if you went across 3, how far would you go up? Can you see it's 9? Based on, choose some x values. To find the corresponding y value, you square it, right? You square the x value to find the corresponding y value. If these were all minuses, these would all be positives, because a negative squared is a positive. Hence, this is my parabola shape. Okay, so as we did with the basic linear graph of y equals x, we started adding things like plus 1. So if you put plus 1 to a linear graph, you'd have slope 1 and the whole thing would shift up by 1. Well, it's the same is true for a parabola. Y equals x squared plus 1, the whole thing shifts up by 1. And in your mind's eye, you need to sort of be able to plot these really quickly. Across 1, up 1, across 1, up 1, across 2, up 4, across 2, up 4. And the y-axis becomes a mirror line. What about y equals x squared minus 3? What's that going to do? It shifts it down below the x-axis. So down to minus 3. When you go to minus 3, there it is there. Go across 1, up 1. Across 1, up 1. Across 2, up 4. Across 2, up 4. Okay, if I showed it to you on a grid so it's more clear. Oops. Okay, so minus 3, across 1, up 1, across 1, up 1, across 2, up 4. Across 2, up 4. Across 3, up 9. Okay, so that's the kind of shape. I wonder if I can fit. The quickest way for me to do it actually is to type it in, but my computer's not going to let me do that now. So you can use your graphics calculator if you've got one to test this out. X squared minus 1, say. By the way, I went menu, I went down to graph function, push execute, And if I just delete that for a moment, to put x in, see that button there? Use that button squared and say put -3 in. Execute, and then you can click that button there, draw, and that'll draw you your parabola. If for some reason it doesn't, it might be because you are zoomed too far out or too far in on your graphics calculator. See this button here, F3, above it says V window. So shift V window, and this shows you your limits on your X axis, minimum, maximum, what the scale should be. And then this shows you the limits on the Y axis, minimum, maximum. And if you just push, I think it might be INIT. What happens when I push that button? Nothing. Okay, so there's a few things that are set up already. If you push INIT, it'll basically set it up at -6, +6, -3, +3. But you can go in here and change them to what you want. Say -10, +10, execute, and then exit out, redraw, and see it goes from -10 to +10. So you've changed the window that you're looking at. Okay, so the graphics calculator helps, and it's a good check, but it's not. You're still going to have to know how to the shifts and things to get a merit or an excellence. The graphics calculator can help you get achieved, but the questions are worded in such a way that it'll ask you to calculate a shift, and you have to know how to do it. Okay, back to my canvas. So far I've shown you how to shift a parabola up, a parabola down. The question is, how do we shift it from left to right? New canvas. Okay, so this cuts at x equal to 2, say, +2. Again, it goes across 1, up 1. Back 1, up 1. Across 2, up 4, across 2. It should cut at +4 here. Okay? That equation looks like this. Y equals bracket x minus 2. Oops, that's a 2. Nah, sorry guys. X minus 2 squared. Okay, good question. Why is it -2? Let's ask the graphics calculator. You can draw more one. Oh, sorry. Delete. Yes. Let's try it. Bracket x minus 2 close bracket squared. Execute. Draw. Okay. -2 shifts it to the right. What is +2 going to do? Shift it to the left. Okay. Where's -5 going to shift it to? It's going to shift it 5 positions to the right.
Why does minus go left and plus go right?
If you're wondering why minus goes right, and this is what you have to do. Remember, this method will always work. Okay, put 0 into here. -2 squared is 4. Put 1 into here. -1 squared is 1. Put 2 into here. 0 squared is 0. Put 3 into here. 1. Put 4 into here. 4. Okay, so if I plotted those 5 points, 0, 4 is that point, 1, 1 that point, 2, 0 that point, 3, 1 is that point, 4, 4 is that point. Okay, so it does actually work. There is only one other sort of shift. We've gone left, we've gone right, we've gone up, we've gone down. The other type of shift you can do is what we call amplitude. So this is the standard parabola. You can have a wider parabola, or you could have a narrower parabola. Okay, now I'm not going to explain this to you. I'm going to get you to play around with your graphics calculator, but you would adjust the number in front of the x squared. At the moment it's 1. If you make it go up to 2, 3, 4 and 5, it makes it either narrower or wider. If you make it go down to 0.5, 0.25, 0.1, it makes it go taller or narrower, but you need to test that out and figure it out for yourselves. Okay, and then you'll be up to 9.01 when you're ready. But there's a video on working with parabolas.